thing, but again, as mentioned, you can put everything into your favorite LLM, and perhaps it will help you more than I do. Yeah. Now, to keep it going, yeah, you have this subscribe. You are subscribing to this obstacles message. The gateway continuously checks what's on this gateway, and if there is someone subscribed to the message that's running over there, it just forwards the message. Now, if it has no subscriber, it just discards it. Now, this is helpful because at any time you can start processes, you can start threads, you can subscribe or unsubscribe to messages. So you can basically decide what to do and when, not just have an entire system running all the time. No. Is this clear so far? I'm trying to keep it simple.
Yes, it's clear.
Okay. Now, if we go into the code, you will see that our main starting point is the main, and here you will see what we discussed. So yeah, you import all those processes, and here you see the process gateway. Yeah, you have the shutdown processes. So yeah, those functions. Basically, here is where the code starts, because here we have the functions. Is the queues I talked before, like critical, warning, general, and it's not info, it's config. So yeah, you have this queue, and you will see that each process gets this queue as a parameter. As you can see here, yeah, all of them get this queue. Yeah, now we have here the process gateway, as mentioned. Have everything installed here. Okay. Okay, yeah, here. Sorry. So you have the process gateway, which what it does, it just starts the thread gateway. So you will see that in our architecture, every time you have a thread inside the process, yeah, and within this thread, you will see that the thread work.
Hi, good morning. Excuse me, sorry for interrupt you.
Yeah.
Could you please show one more time the picture that you were drawing, please?
Yeah.
Thank you so much. Thank you so much.
Okay, you're welcome. Yeah, you will see in this thread, I will walk through the structure of this thread, because as you can see, we have this thread with stop, which is inherited. You will see that thread work, which is like the main loop inside the thread. If you go in there, you will see that this run like the run method of the thread itself. So this just keeps going continuously. You will see that it's looking on a queue. First, it goes into critical, and if there's a message on the critical queue, it takes the message. Otherwise, it goes down with the prioritization of the queue. So this way, it handles first the critical messages, then the warning, then the general, and at the end, it handles the configs. Now, if there's a message on the critical queue, it stores this in the message, and it goes into the send method. Now, send method, as you can see here, it looks, hey, I want to know the information of this message. You will see here, if you go into utils, we have messages and we have all messages. You'll see that each message, which is defined, has a queue that the message should go on. So let's say this is main camera is like the main image of the camera. So it should go on the general queue. Who owns, so who's supposed to be the only thread that sends this data? This is just a tip. Never have a message that can be sent by multiple threads. So just define a different message. It will ease your life once the code gets bigger. Yeah, so the thread camera owns this message, so just the thread camera can post it. We have an ID. the idea you will see that is incremental within the same thread. So camera can send 1, 2, 3 messages, whatever, and the message type, which in this case is string or boolean. Yeah, you will see that it takes the message is sent by the owner. This is the ID. This is the type, value, whatever. Now it looks what it does. It looks into the subscription list, and it looks for who's the thread or whatever that is subscribed to this message, and just forwards this message to everyone. So the gateway is pretty simple. There are some more features if you go inside, but yeah, I think you got the main idea. Is it pretty clear so far? And what we do on the config queue, basically we send the message to subscribe or to unsubscribe to a message. Coming back to this picture, the camera obstacles sends on the config a message, the gateway gets it, and it can be, hey, subscribe me to the obstacles message or unsubscribe me to the obstacle message, because you can find some cases where you want to, I don't know, you don't want to always check for those messages. You want to check for some messages just when you are on a certain state. I don't know, let's say you want to look for pedestrians on the road only when you see the crosswalk. So yeah, basically you are interested if there are pedestrians on the road only when the crosswalk is there. So with the camera you see, hey, there's the crosswalk sign. I want to subscribe to the message that says, hey, there's a pedestrian. And when I got over the crosswalk, I want to unsubscribe to it because I don't care. You name the cases. It's pretty much that's pretty much it. Now, if we go again into the main, you see again you have this this gateway. You have the message handler subscriber. Now, what this does, message handler subscriber, you can see here, it's a method that we use in order to subscribe, basically, to a message. Now, let me show you, hopefully I find how it works here. State change subscriber. Yeah, so the while true is the running method of the main. Basically, it continuously looks if there's a message, so receive a message on the state changer subscriber. Now, coming back here, what this means, I want to subscribe to the message state change. If you go into utils or messages, your state change, you see, this is a message owned by the state machine. So basically, the main is looking on messages that are sent from the state machine. So here you can define your state machine, how it works. Yeah, and it just looks for, hey, are there messages on the state machine? I just want to get the last message. So what this means, if there are, I don't know, 3 messages on the queue, I just want to get the last one because the other ones are not something that I care. So I just want to get the last one. And basically this state change subscriber handles everything. If we go into the subscriber, you will see that you have this receive with block. Those are methods like you receive data from a pipe and you block everything. You ensure that there are no other messages on the pipe. Yeah. Or you can read the messages without blocking everything. So yeah, here is some logic inside. I won't go through everything. Basically, once you defined a message that you want to subscribe to it, you can subscribe and unsubscribe on the same method. So on the same object. So you have the state machine, and here you can go, hey, state machine, unsubscribe from this message. So you won't get messages in your run, but you will still have the object. So the object will still be available. And then if you go again, subscribe, then this receive will get you some information. Yeah. Is this pretty clear so far how the messages work? No questions? Okay. Okay, so yeah, you have the message subscribe and everything. Now here you will see lots of other processes and events. Yeah. Now, if we go inside the process, let's keep the dashboard to after this. Now we can choose the process, the camera process. If we go here, we see inside source, we have a gateway, we have utils, then we have hardware, and in hardware here message handler subscriber. So this process, it listens on the change, which was also valid in the main. So when the state changes, I want to do something. So yeah, you see here, it looks, hey, has the state of the parking procedure in your application, and during parking you don't care about camera. Let's say you want to keep it simple, then you can just disable the camera threads while the parking is ongoing, or maybe you can find some other use cases, but basically you can put on pause a specific thread. So yeah, if the message is, hey, enabled, then resume thread. If the message is, hey, enabled false, just put the pause on thread, put the thread on pause. This way you spare some energy in your car or some computing power or whatever. So this is a pretty straightforward example with the camera, but maybe you find some other use cases where this can turn out useful. Now, let's see. So you have the process camera, and you see that this inherits a worker process. Worker process, you see here, it's basically the behavior of a process. It has this queue lists, so you put where the queues end up when you create this this process, or any process. You have the daemon, the threads. Those are some specifics. If you want, if you're interested into multiprocessing in Python, you can go through them. But the examples are pretty straightforward. During the run of the process, what it does, it initializes the threads, and then it's making sure that this run thread is going. Yeah, here is some logic. I don't think it's necessary to go specifically through everything because we'll learn tomorrow in the presentation. But yeah, here you have the threads, and in the thread, you see that you have this thread work, which does the actual work. So within every thread, you will see this method where you put your logic for the thread. Again, if we go into process camera, you see that hey, it's declaring this message, it initializes the thread. And if we go inside the thread, you will see that the logic for capturing the videos is within this thread work. So you have the thread work. In this case, is like, hey, yeah, if the camera is not available, just keep processing. Otherwise, let's see, is the recording service being activated or deactivated? Because recorder subscriber, as you can see, this is a message. If we go up here, you'll see recorder subscriber. So this is basically, hey, I want to subscribe to a message that tells me if I should start or stop the recording. Let's say you are doing some dry run tests. This is something that you also can see on the dashboard. So if the dashboard tells me, hey, you have to start the recording, this is where it's handled. Yeah, so does someone want me to start the recording? Okay, if the recording goes to false, it means that someone wants me to stop the recording actually. Otherwise, it defines, hey, this is how the recording should go. Yeah, so the dimensions, how the naming should be for this recording, and yeah, basically some setup for how the camera should record stuff. Now, if you go down here, you will see what it does. It goes into camera capture array, so it has two channels where this thread gets the images from the camera. Main one and serial one. Now the main one is the one with full size. So it's the one that maybe you want to do the image processing on. Serial one, it is the one that is smaller. So it's a smaller size, which is just sent over to the dashboard so that you have an idea of what the car is seeing, because there's no point to just send the complete image to your phone or to the computer. We just define a smaller one. Yeah. Here it encodes those messages. Yeah, here it encodes those messages. And then both the main camera and the serial, so the main image, encoded image, and serial encoded image are sent. This one is a message handler. If we go up here, just this time it's a message handler sender. So yeah, it handles the main camera message or the serial camera message, and just puts both those messages on the general queue or on whatever queue it is defined. In this case, is the general, but it just puts it there, and yeah, from another part you can just subscribe to it and use it as it is. Yeah, everything clear so far? I know it can be quite confusing, and the code is pretty big, but yeah.
Can you explain this again?
Everything?
Not really.
Here is some new message.
Okay. This is the message? Okay, yeah, let's go briefly through it again in this case. Yeah, so you have process camera, which what it does, it just takes care that the threads are being kept alive. Basically, this is what you have to remember, and how the system as we built it is designed to be used. But if you have other ideas, you can do so. You can do some image processing in the process, not in the thread. Now we just use the process to keep the threads alive. As you can see here, init thread, which is part of this worker process, starts the threads. And then, yeah, the process itself just keeps it alive. Now, the thread, here you have some initialization steps, like message senders. So those objects are going to be used to send the messages. Now, recording sender. This is a message that sends actually the recording message. Yeah, the main camera and the serial. Sorry? No? Okay. You will see that here are the messages that are supposed to be sent from the thread, and here are the messages that are supposed to arrive to the thread. So this thread can receive messages like record, so start or stop recording. If you want to create a movie, so let's say you have a track, and via keyboard you just drive the car, and you say, hey, I want to record this so that the image processing guy can work in the future. So yeah, you send a message, hey, start recording or stop recording, because you don't want to record every time. Or I don't know, you have another place in your code where you want to send the brightness. So hey, right now I know that there should be I should expect images that are darker, or I'm in a darker environment. I send the brightness setting. So all of those are messages that are supposed to arrive to this thread. And this is what is supposed to get out from the thread. So this is output, this is input. Now, thread work is like the run part of the thread. So this just keeps going until you stop the thread or put it on pause. What it does, again, you see here, recorder subscriber. Hey, is there a message on the recorder subscriber? Now, if there is no message, then the message is going to be none. So this code is not going to be executed. If there is a message, like someone is telling me, hey, you should start recording, or you should stop recording, because both are valid. It's like, hey, the message, I'm expecting something. Okay, let's see, because this is a Boolean, so true or false. If it's false, it means that the message is, hey, stop recording. So it means that someone started it before. So just release. So this is a method from the camera itself. Otherwise, it means that recording is true. So I should start record the message. Everything. This is some basic setting of the camera. Now it goes forward. So this was the input. Now we go into the output. You have the message, the main request and the serial request. So the two channels, main and lords from the camera. This is how the Raspberry Pi Camera 3 is working, and its library. It takes these images. So here you have right now raw images. It's looking, hey, should I put this image in the video writer, because the recording is true, as you see here. The recording is set to true or false. So if the recording is enabled, it means that this message should go into the video. This is pretty basic. Now serial request. Basically, what these do is it encodes the images, the image in two channels that has been recorded. Why we have two channels? Because maybe you want to have two dimensions for the images. You want to have the full 4K dimension, or you want to have the 63 pixel by whatever dimension. So the 630 will go into the serial, as you can see here. This is a smaller size image, and this is a big size image. Why we have two is maybe in your image processing, you want to check the big image, so the full size one, but you also want to know on the dashboard application what the car is seeing. You don't care about resolution that much, you just care that the camera is working or whatever. So this is why you have two. two channels on the camera. And what you do after everything, basically, you just send this main image on the queue and the serial image on the queue, where they are defined. Yeah, here are some other functions that just config everything. Surely, if you stay a little bit on this, depends on who's gonna work on what, you can work for it. And here you also see the config for the small image, for the LORS channel, which is this size, and the config for the main channel, which is this size. So those are some settings of the camera. If you go to this datasheet, you can see you can also get a bigger resolution on the camera, but in this case, the FPS is going to lower down, as you will see probably when you work. But yeah, basically initialize the camera. This is the method to stop the thread, to do some configurations. Yeah, basically this is pretty much how the structure is going is with the processing with the threads. Is it clear or no?
Mm-hmm.
Okay, do you hear me? I have a quick question.
Yeah. Yeah.
Yeah, so how exactly do we define when the image acquisition happens? Because if I understood correctly, we have the worker thread, which would be called every 0.
Thread works, so where actually works. This is a pausing mechanism by the pCamera method.
Yeah.
What it does, it's actually looking if there is a new message on the waiting, so a new image waiting. Let's say you are trying to read too fast. This one will block until there is an image coming. But maybe
Okay.
you can find some settings on the pCamera library where it says, hey, I don't want this function to be blocking. And in this case, it can return you, hey, none if there is no image, or the image itself if there is one. Yeah, some settings on the camera. Perhaps here in the init camera, we can find some configurations. Basically, I think this is where you should play with this setting. Yeah, so is the config parameter, and this just goes into a camera. But if you go into the library, you can find some documentation on it. Yeah, perhaps it can. Yeah.
Okay, yeah, so we set the FPS of the camera, and then our thread will ask for the picture and wait for the newest picture.
Yeah,
Yeah.
yeah.
Okay,
This
thank
is
you
how
very
it
much.
works. But if you want to set the frequency of the thread running or the frequency of the camera running, you will see different behaviors. As I mentioned, the camera can be configured in the main channel at a bigger resolution. But in this case, the FPS will drop. So in this case, I think it goes around 30 FPS. But if you go to bigger resolution, you go to 15 FPS, or if you go 4K, I think it's around 5 FPS. So it's the setting of the camera. You just play with it and find out what fits your work.
Okay, thank you.
You're welcome. Yeah, as you can see here, it's like the P camera 2 library. This is something that you just use for the P camera 2. Okay, now here in the hardware we have this camera. Then we have the serial handler, so the process that just communicates with the serial, so with the Nucleo. This process, you will see, it has a log file, so it stores all the messages running in this thread in a log file. So this way you can check later what's happening. And the log file is actually handled here. Anyway, this log file stores what's going to the Nucleo and what's coming out of the Nucleo. So if you make some changes there, you can see. Now you will see that again, it has some subscribers. It subscribes to some messages like state change or serial connection state. State changes look for the state machine. So when there is a change in the state machine, it looks, hey, how should I behave in this case? Maybe you don't want to communicate with the Nucleo in some cases. This you will see. The serial connection state, you're like, hey, I don't want to talk to the serial. Maybe you find a use case there or how to use it. But basically, it initializes the subscribers and the senders. So message handler, sender on serial connection state. So it just sends over, hey, my serial connection is working or not. There are some other methods specific to this serial connection. I won't go again for everything. It's like trying to reconnect to it. If you play with the cable or if you plug it out and plug it in, it retries to close the serial connection or to do it. Anyway, as you can see, some private methods. Maybe you will have to work on it, maybe not. But yeah, this basically. Now, what this does, again, you'll see this initialization thread method. It has a thread for reading from the serial connection. So reading what the Nucleo is sending, because this is a word connection. So RX and TX. It's reading what's coming and it's writing what's coming. Basically here you can find those threads, read and write. So maybe we go into the write method first. You will see here lots of subscribers compared to the last one. What you see, hey, we have the CLEM subscriber. So when someone wants to tell the Nucleo, hey, I want to change the CLEM from 0 to 15 to 30, we went through it in the kickoff, but basically CLEM 0 is the Nucleo should not do anything. CLEM 15 is the Nucleo should just interact with the sensors. So I should be able to read how much battery I have left, or I don't know what's the speed of the car. And CLEM 30 enables the motors. So if I have set CLEM 15 and I send a steering command to the Nucleo, it won't work because the motors are not enabled because the CLEM is not 30. Yeah, so this is basically. So yeah, we have the CLEM, we have the control subscriber, so a control method in the Nucleo. Whatever steering subscriber, so when someone wants to tell the Nucleo, hey, steer a certain angle, it posts in here, the speed, brake, toggle instant is like, I want to enable the Nucleo to tell me what's the instant consumption on the car, or I want Nucleo not to tell me what's the instant consumption on the car. So this is a Boolean. If we go into all messages, we'll see it. toggle battery level. So again, I want Nucleo to tell me what's the battery level in the car or not to tell me. Resource monitor is the message which again toggle. I want Nucleo to tell me what are the resources that it's consuming right now. I want to get the IMU data from it. I want to get the calibration information from it. I just want Nucleo to tell me it's alive. Or I want to know what are the steering limits from the Nucleo. This is something we'll go for in a moment. But basically you have all these messages. And if we go into the thread work, which is the run method of it, you will see, hey, I'm checking the clam right now. Is there a message on the clam? Okay, this is how I want to behave. Is there a message on the is a live subscriber? Okay, this is how I want to behave. So basically, it's lots of behaviors when there is a message coming to the Nucleo. This is a longer thread. Also the read and the process serial handler, but basically they are pretty simple. It's just kind of lower level coding. So yeah, this is why it's bigger. Does it make sense so far?
I mean, yes, it makes sense, but I have a question.
Yeah, please.
Yeah, okay. How to send, I mean, like a driving command from my process or my thread into the Nucleo?
So you just, let's say, I don't know. Yeah, let's do a live example. Here, you want to see in the thread right, what is the steering? Okay. Break subscriber limit, server to subscriber. Let me see. Steer. Where is steer? Okay, that's the option. So you have the steer motor subscriber. You will see that this subscribes to the steer motor. Steer motor is a message you have in utils, all messages. Here you see steer motor. Now in the main you do self or whatever. Let's say steering. Let me see. Subscriber. Publisher. Just one. You see, you have this message handler sender. This way, you go here, message handler sender, and you go, hey, I want to send, you pass it the queues, and you go, hey, I want to go with the steer motor. Yeah, so it's okay, queue, and you're not going to battery level, you're going to go with steer motor. Okay, now in here, you can handle the sending, and you go just steering dot send message handler sender. Let me go here. You have the method send. It's going to be like send, and if I'm not mistaken, it should be something like this. 1, 2. So you are sending the steer 12 degrees to the motor. So it's pretty basic. So perhaps there's a little bit of a difference right now, but it shouldn't be that much more different than this, because As you can see here, it expects a value. So yeah, you just go with this value to send to. And basically, because this thread write is subscribed to this steer motor message, it will just handle this sending. So if you do the sending from the main or from whatever, it doesn't matter. This write is subscribed to it. So whenever you put a message on there, it will just see it, receive it, and send it to the Nucleon. Is it pretty much clear?
Yes, I think so. I have another question.
Yeah.
Is there any way to know, like, which process or processes or threads are currently running? Is there a way to know that?
This we don't have, but basically you can just comment if you want. If you comment, they are not going to start. But I think also if you look into the state machine, you should see who is running and who's not. Because in the source state machine, let me check. So source state machine, here you should see the behavior of a state and see how the entire system is behaving in this state. So yeah, it's not directly configured, but from the system mode, from the state system mode, yeah, sorry. So from this system mode, you will see that, I don't know, those processes are enabled and they are not enabled. So maybe you can go from here, but as for right now, there's no straightforward method. Hey, just tell me this is working or this is not. But it should not be that hard to set up.
Yeah, okay. But is the code itself documented? I mean, like each function, what it does, what its functionality, and these things, or not?
Yeah, it should be pretty documented. I mean, the definitions should be pretty straightforward. But if you see something that is not that much clear, just beat us up, and yeah, we help you out. But we try to keep everything like under Misra, so it should be pretty straightforward. Here in the demo section, you'll find a fresh start section. Basically, we prepared for you an image with our code. You just have to pull it out to download it. Here are the steps to put it on a completely new SD card or Raspberry Pi. It's like 5 minutes steps. If you don't include the download, this I don't know what's your speed, but you can just download it and put it there. If it's a Raspberry Pi 5, it should work. I'm not sure about Raspberry Pi 4. I think they're not because the OS is different. But yeah, basically it should work. Or if you want to do everything from the scratch and you don't like our image because of whatever reason, you just go and build everything from the scratch. You get a clean Raspberry Pi image. Yeah, you connect to your Raspberry Pi via SSH. This is how we suggest you use it. Upgrade the system, configure your Git credential, or install some other packages as needed. You will see while you go, just clone it, and it should be okay. And this is also how you install the required services. I will just go through them in a moment. Yeah, but yeah, basically, if you get another Raspberry Pi, it should work. maybe even if you get another an NVIDIA, it should work. I'm not sure there. If we have someone that is trying to port everything to NVIDIA, maybe they can lend a hand, but it's not that much platform dependent. I mean, we don't use that much of a Raspberry Pi. Perhaps the comments to see how much computational power the Raspberry Pi requires, that's going to be different on NVIDIA, but otherwise it should be pretty similar.
Okay, thank you.
We tried this method, but it won't work.
It won't work? You try to run it and it's not working?
Yeah.
Okay.
From
Okay.
0 all to the end.
Okay. Yeah, we never tried it. We are not that much fans of NVIDIA boards at the moment, but yeah, who knows?
No with the NVIDIA, with the Pi.
With the Raspberry Pi?
Yeah.
You try to just put our image and you have a problem?
With the image it work, but with the build from scratch it doesn't work.
And what was the step that did not work?
We don't know. We tried, it runs every step, but the car was stuck.
Okay. And you installed also the services?
Yep.
Perhaps you have a problem in the service setup. I think that's it. Because, yeah, let me also discuss on the service setup, what it does. So this Angular auto start, it's a service that starts the Angular, so the front end of the code automatically at startup. This way you don't have to start it. Because perhaps this is what you also, if it can be my guess, this is what's not working. I don't know. But yeah, basically it starts the front end. Here you don't have to touch it. If it starts a startup, you don't, yeah. Anyhow, if you save your project, it will update automatically. Now, the brain, this is a service that just listens on the dashboard. If you started the dashboard, maybe you see at the beginning a red message. I don't remember precisely what it states, but basically it listens when someone is trying to connect to the dashboard, and if someone connects, it starts the main.py. This can be another point where your code is blocking. I'm not sure. And yeah.
Hi, Rajesh. I have a doubt.
Yeah, please.
We are planning to use a Jetson Nano, and over that we are planning to change the code as well. We probably want to build everything from scratch in C++. So is that suggested? Like, should we be doing that?
Well, if you want, of course you can do. If it's something we suggest, I don't know. It's up to you. So the challenge is completely free. If you want to do it, feel free to do it. Yeah, I don't know what to tell you here. It's up to you. So if you think that you can do better and do in C++, yeah, just go with it.
Okay, sure. Thank you.
Because surely our code is not perfect. You will find flaws in there. Once you go in, what we did with the code is just we try that it works with what we have. But once you get your project bigger and bigger and bigger, it may not fit what you need. So yeah, just feel free to do how you feel.
Okay, perfect. Thank you.
You're welcome.
I have one doubt. So the car we got, it is like pre-installed with this software, right? Like the Raspberry Pi image are already installed, and this GitHub code, which is publicly available.
Yeah.
Okay. Yeah. So on the top of that, we have to implement various functionalities, other features like line detection and all.
Yeah. Yeah.
Yeah. Okay.
When you get the car, this demo steps should work plainly. This is how we tested before shipping it to you. Now, if something got damaged during the shipping, I don't know. But this should work straightforward. It is what-
Yeah, this means this front end was means we were able to connect it, and then in the manual mode we could run that car. But the only doubt we have is with respect to first report, what is expected to do? Like, do we have to change the code and like implement functions, or just prepare a report and make a car run?
just try to do your best. I mean, no overkill, like 20 hours work, but I guess in my view, it's pretty much enough if you manage to create another process and you manage to do a parking procedure, because this is just a sequence of events. You're like, hey, just keep the car going up until I see, I don't know, there's something in the middle of the road, because there you have some image processing as well, and then you just say, hey, start the parking procedure. It can be even if you place a white piece of paper on a camera, like the car goes, you place a white piece of paper and it starts the parking. So it's how you feel. There's not
Okay.
a minimum.
And yeah, I got. So suppose if I want to go back to the already flash code we have on the car, so we just have to rerun, means build the code which is available on the GitHub, like the code which you are explaining right now.
Yeah,
Yeah, okay. Yeah, thanks.
that can be an approach. So the approach is up to you. If you want to go with our code, this can be an approach. If you want to go with everything from the scratch, you can just start and build the Nucleo or whatever, the brain from the scratch. So it's up to how much your team can handle.
Okay, thanks.
I have one question, sir.
Yeah, please.
Sir, what will be expecting for the first project submission? Meaning that on 22nd we have the first submission now. So what will we be expecting? Because this is the challenge is total 10 months long. So all the team might they will be working on some more part that it will take some time. So what you are expecting for this 22nd for the first project submission?
Well, as I mentioned, from a code point of view, anything can be acceptable. So again, it's up to the team. So I don't know, maybe you want to go with our code, maybe you want to go with an NVIDIA. An approach is also, hey, someone is working on an NVIDIA, is trying to set up, someone else just installs the Raspberry Pi image on I don't know, you can create a Docker container and put it in VirtualBox and just try to understand what's in there. So it's up to the team. I mean, I wouldn't have an answer, hey, you have to do this or that. You decide. I know it's not a straightforward answer, but it's the best that I have. It's up to you. So it's up to how much you want to know.
So it's totally like whatever we can able to do till that we need to submit.
Yeah, I mean, whatever you can do, just be sure to submit. I mean, we won't come and look for you in your house or university to, I don't know, or ask you for money because you didn't do much. So it's up to you. It's up to you.
Okay, sir. Thank you, sir.
Rodrigo. Yeah, Rodrigo, please.
Yeah, I have a question about the KL0. I understand. Well, I'm not sure, but it's like a software set. Like in KL0, the serial port is open, and it's not. Yeah, it's not connected.
In the KL0, so the serial communication is working every time the system is on. The KL0 is just a safety feature, if you want to call it like that. Is like making sure that nothing is working. Because an example, when we worked in the project and my team had to develop something, we just put a car on on a table, and at one point, without touching anything, the car just went full throttle. So it went into the wall. So some other teams had this issue during the years in the challenge. So yeah, it's a safety feature. Just making sure that if you don't want the car to move, it won't move.
Okay, thank you.
You're welcome. Antonio?
Hello, I have two questions. One question is, let's say I want to implement this system in ROS 2. Like, what are some things I need to know about it? And other thing is like, is there some specific reason you have chosen to implement it yourself rather than in ROS 2?
Yeah, we chose to implement everything in Python because this way you can port it easily to whatever framework you want. We felt that if we chose to implement everything in ROS 2, we will limit everyone in ROS 2. But this way, if it's in Python, you can go, I don't know, add another board, make the boards talk together, or go with something similar to ROS. So yeah, we found that it's not that much limiting. So it's kind of easy to port into whatever kind of system. Yeah, as for what you should be careful when you use ROS 2, well, there are lots of things to be careful, but yeah, I wouldn't know to be that specific. I wouldn't know to be that specific. So yeah, you will see where you go.
I mean, do you think it's like a wise idea to do something like that?
Yeah, it is a good idea. You can move there if you want, because this way you can also add multiple boards if you want to make parallel computing, physical parallel computing. It's a good idea, but again, you have to port everything. So you have to analyze, as Radu told you in the kickoff. You have to analyze what are the risks, what are the benefits, make a plan, and go from there.
Okay, thank you.
Okay, I will also get the 3 questions in the chat. So if we got this correctly, we can create a message in our case steering. We set into the queue with the message sender function, and then we send it to a steering subscriber, right? So this is the bare minimum. As you've seen, there are 2 lines of code to do this. If you feel that 2 lines of code is enough for your report, go on and do it. Otherwise, you can go into more details. So just start touching the code, because you will understand more things when you touch it. Mechanical question: if the size of the car doesn't change, but the wheelbase position changes, front overhang increase, rear overhang decrease, is that okay? Yeah, I think it's okay. So you can elevate or increase or reduce the elevation of the car. So it doesn't matter. Yeah, you can. Any kind of approach you choose.
I have another question.
Yes, please.
How can we access the board with our computer and handle it inside the terminal with commands for debugging? Because we can figure it out. Only works it once, the communication, and for like 10 milliseconds.
Okay. Radu will get through this in the next week, so just prepare your questions. But this guide that you have here for the embedded platform, it should be pretty straightforward. I won't go into details. Radu will help you next week, but you should be able to set up everything if you go through these 2 pages. They're free if you consider also the debugging. Yeah, okay. Now coming back to our code. I won't go through all the processes. Yeah, basically they are just two processes. But yeah, we went through the gateway, through the hardware, through the state machine. I will let you understand it. Basically, it's a transition table. So here is defined how your system should transition between states. Here we defined just the states of auto, manual. So this is what you see also in the, oops, not here, in the demo. If you go down here, you will see that you have driving mode, which is stop, manual, legacy, and auto. Those states you find also here. Auto is basically your normal automated driving, whatever. Manual, so you want to drive the car manually. Legacy is for the legacy round, and stop is, hey, the car should be in stop mode. Yeah, but this is a transition table. Here you define.
Sorry for interrupting. What is the difference between auto and legacy?
If you went through the regulation, you see that we have the technical round, which is the auto. So there you can have one kind of behavior. And if you go into legacy round, you may find that you need a different kind of behavior. So you decide to use a process or to not use a process. It's that far. It's that easy. Okay. Yeah, so here you see the states, the system mode. So what describes each state? So you'll see that in default mode, the camera process is enabled, the thread resolution is, I don't know, you see that, I don't know, in default mode, you want the resolution to be 720. In auto mode, you want it to be 480. So you can define multiple things in this state machine. It's basically you define how your system should work. You see that, I don't know, when I'm in stop mode, I don't want the serial, I want the serial handler to work because I want to still be able to communicate to the Nucleo. I want the semaphores API not to work because I don't care to talk to it. And the camera, I don't want it enabled, I want it stopped. So again, you define this behavior in your code. But basically, you have like the process, the name of the process, and then how this process should behave and how their threads should behave. But then if you go into the code, you will see how to handle everything. And in the state machine, you will have the behavior of this process because it is a process. It just checks. Basically, it makes a request. Hey, I want to go into this mode. It checks, hey, is this transition valid? Okay, then we can change into this mode. If it's not valid, it's like, hey, warning, invalid transition. I mean, if you interact with it with state machine, this should be fairly easy for you. But again, I won't go through all the things because it can get pretty overwhelming. This is just an idea for you to understand where to touch things, because if I'm going to ask you at the end, probably you won't remember much, but you will just remember, hey, there is a state machine. Okay, the templates, we went through them. Utils is basically those messages and some other stuff. Yeah, gateway, data is, yeah, I didn't pull this, but basically is the APIs that interact with our localization system and with the semaphores. Let's maybe go also for that. Okay, we have rain. And in this
will we be going through the localization system today, or?
Yes, we can go one moment.
Yeah, thank you.
Okay. Oh, sorry. Here, so yeah, you will see data. I didn't pull this code into my Visual Studio right now, but I will get through it from here. Basically, you have semaphores. So a piece of code that interacts with the semaphores in our location. If we go in here, you will see again that you have a process. The structure is pretty similar to what we discussed on the other things. The process is just handling that the thread stays alive. And then it handles that you can implement the stopping and the pause of this process, of this thread. Now, the thread, what it basically does, this is pretty simple. In this case, you have the listen port. Don't touch it, keep it as it is. You have the listen port. It's listening for UDP messages, as you can see over here. It's listening for UDP messages. Reactor is a part of the Twisted library. Yeah, so it lists on this port, and this object handles the behavior. If you go into the UDP listener, which is this one, you will see what the behavior actually is. Here you have the initialization, nothing fancy. It just describes the message sender, as you've seen on the other side of the project. So yeah, you have the message sender. So anytime there is a message that is sent over the 5007 port, so what is defined in the process, sorry, in the thread, anytime there is a message, it gets this message like, hey, datagram decode. The message comes into a datagram. So this is how the datagram protocol behaves. You get this message, you decode it via UTF-8, then you put everything into a JSON, so to just use it like a dictionary, and then you are like creating the message, which is like, hey, I got the message from the semaphore with ID 3. The state of the semaphore is red or whatever, and the semaphore has the position X and Y. Then it creates this temp message, and it puts it on the queue. So nothing fancy for the UDP listener. Yeah, this is the easy one. Now, there is this other API, which is the traffic communication, the process traffic communication. Now, for right now, you don't care much, and you won't remember if I tell you this, but when you come into the challenge next year, if you do manage to qualify for the finals, this key you have to change. You will see that it's looking for data in source traffic, source data, traffic communication here, so useful. And here you have this public key server test. So this is a public key, which is used to validate that the server you are trying to communicate with is actually our server. Why we do it? Because we also give you the server of how we communicate here. So this way you can test it. On your computer, you start the server, and on your Raspberry Pi, you start this client that I'm just showing. And it's verifying that the server is actually your computer. Now, in your home, this won't be of much help. But when you come here, you just have to delete this test, because this way your code will use this other key. And for this other key, only we have the private one. Now, how this works is actually the behavior in the thread. If we go into the thread, you will see that you have here thread traffic communication. I will try to keep this as simple as possible. Because you wouldn't have to, you don't actually have to touch it, you just have to understand how to play with it. You have the thread traffic communication. This listens on the port 9000 for someone. So this is the client. Let me create a new one. No, computer froze. Okay. No. Okay. So here you have the client. Now, the client, what it does is just listens on port 9000. It doesn't know where the server is. It just listens via UDP, as you can see in the code. Listen port is is linked to a UDP. It listens on this port. Now, there can be or there can be not a server. Maybe at one point, let's just put it like this, a server appears on the network. And this server is like, I don't know, streaming. Just consider this star is streaming. It's streaming on 9000 ports. Now, what it does on the 9000 port, it streams, it's actually IP. So where the client can expect to find a TCP IP connection. So on this port, it sends a message. It doesn't care who listens to it. Then the client listens. It's like, hey, someone wrote me on the 9000. Let me establish a connection with it, a double-way connection, if you want to call it like that. So a TCP IP connection. And it's trying to reach the server on this IP. And it's trying to validate that the server is actually the server. So this is where the key that I showed you comes into play. It validates with that key that the communication with the server is actually this server. Is it clear so far? Does it make sense? I mean, it's not the most technical drawing, but yeah. Okay, so once it made sure that the server is the server via the public key, there's where the magic begins. We have the TCP IP client, which, if we go over here, let me check. Yeah, it again has this data received. So the TCP IP client, anytime it receives data from the client, it puts it into this factory send location, and yeah, it just puts it into this send message and sends the position, because our server sends the position. The TCP IP client, it gets this position and it puts it in a message to just post it in the queue. Then the example, but in the main, so in the process, you have an easier approach. So like, hey, you start this this thread, and when you want to send data to the server, you do it like this. So if you're like, you have to just use this shared memory, you put, this is how you send the position to our server. This is how you send a rotation, how you send the speed, and how you send a point of an obstacle that you encounter. Basically, this is the example, yeah, and this is how you get the messages from the server. But once you start the server on a computer and the client on a Raspberry Pi, it will make much more sense, and yeah, you can walk around how it works. If you're really interested in how it works, yeah, go with it. If not, just use it. Also, for these locations, if you start your server on a computer and the client on your Raspberry Pi and the dashboard is running and everything, you will see here that the car is going in the map. So this is also a feature that the demo has. You will see that the car is walking around the map. Yep. Is it pretty clear?
Yes, I think it's clear, but I have one question.
Yeah, please.
Okay, so it tells me my position and orientation, but with respect to what? I mean, what's my first frame, fixed frame?
It it doesn't tell you the orientation, just the position. The orientation you have to define, and also your speed. Now, with respect to what, if you go into the documentation on the racetrack, you'll see here the X and Y axis. So this is the point 0, 0. So whatever is sending you is like this coordinate. So X is on the right, Y is on the left, upwards, and the coordinates are in meters. So yeah, it's like, yeah. Is this the question?
Yeah, okay, I think this solves it.
Okay, good. Now, okay. Yeah, just one moment, sorry. Okay, now, sorry for that. The last thing that we should look into is the project process dashboard. Now, what I can tell you about this is, again, it checks the pretty big, and honestly, I think that some LLM will be able to help you more than I can here. Yeah, basically, it's all this dashboard is what you see in the demo. Yeah, and an explanation. You can have. Yeah, 1 second. Wait, where is it? Yeah, in here. Yeah. Now you have some fixed components. So those components that you see over here are already listening on the messages that are running. So the messages that you find in the all messages.py that we talked before, some of them are handled here directly, like the battery level, the speed of the car, battery status, driving mode. You have here also listening on a message that's like, hey, error to the road. It's like if the car, you will see, if you post that message, then the car moves from left to right. Now the steering angle, this is the feedback. So this is the feedback that for the steering angle is the feedback. So the message that you've seen on the Nucleo, because when you send to Nucleo a message, hey, steer 20 degrees, the Nucleo replies back. It's like, hey, I made a steer of 20 degrees. And this steer you will see over here. And this is because the dashboard is actually subscribed to those messages. Again, this works for the battery speed and so on. We also talked about recording. So here you have the start recording. So when you press this, the message goes on the queue, general queue. The message starts recording, goes on the general queue. Then general queue looks, hey, is there someone who wants this message? The camera thread is looking into it. We've seen the code. It's like, hey, someone started, sent the message to start recording, and it will actually start the recording. Now, after that, you will see the image here. You will see also the image saved in the output file, or how you define this file. And when you press stop recording, it will stop. Now, this image that you see over here is actually the LoRs channel that we've seen in the camera thread. So, just to have you understand, it's what you've seen over there. Those messages, like the CREM, is what goes to the Nucleo. You know that we've seen, hey, the Nucleo is subscribing to the CREM status. This is who sends the CREM status. The driving mode is actually the setting that goes to the state machine. So you will see, if you go into the code, that the state machine is subscribing to a message. Actually, that message is owned by the dashboard. Again, if you go into the all messages, utils, messages, all messages, you will see that, I don't know, state machine, yeah? In this case, is name state, is a message owned by the dashboard with ID 13, and the message is going to be a string. Yeah, so all those messages you are going to be able to see from over here. Now, predefined movement. This is a feature that allows you to send to the Nucleo actually a predefined movement. Like I want the car to run for 3 seconds. I want it to run at a constant speed of 20 centimeters per second with this steering angle, which goes somewhere between -18 and +18 degrees. If you press submit, this message goes to the thread right, which is actually subscribed to it, and then sends the message to Nucleo. Then Nucleo replies, hey, this is my steering angle, and this is my speed, and those two, so the speed and the steering angle, will update. Yeah, then you have the usage of the Raspberry Pi, so how much everything uses out of it, how much Nucleo is using. You have some other notifications for, like, I don't know, you see on your camera processor where you do the image processing, you see a sign, stop sign. You send this message. We actually have this stop sign. Sign. There should be one somewhere here. Let me remember. I have to check which message actually owns this, but there is a message who is publishing here, but I think it's a message that publishes everything. Yeah. If I go for everything, perhaps I will find, but steering motor, process cars, horse, process camera. There it is. From Nucleo, from Roxys, serial handler, from state machine. Yeah, I have to check, but surely there is a message. Perhaps I will write you on the forum. I don't remember right now. Yeah, but when you put this message on the queue, you will see that those things appear over here. Yeah, and basically all of this is handled in the process dashboard. In the process dashboard. So the process dashboard is actually subscribing to all the messages that go on in your system. Now, some messages, as you've seen in the documentation, are handled here. You can find it here. So under source dashboard, front-end app socket, this and handle events. So this is where it's stated how those messages behave. In the process dashboard, you see how they are handled, how everything goes around, and yeah, all the messages that are running over the over the network and are not specifically handled in here in the handle events, but perhaps let me go here. So dashboard front-end source app WebSocket, and then I have this one. Here you see all those messages. So those messages are specifically handled. If there is a message running on the in the system that is not specifically handled, then this message will show up in the JSON table. Now, what this JSON table is, you can see over here. Yeah, those are the messages that are running and are not specifically handled, like steering limits, IMU acknowledge. So IMU acknowledge is like the IMU replies with I'm alive, and this is the IMU data. Now you can define in this JSON table also some messages that you want to send from the dashboard. Again, maybe from the dashboard, you want to, I don't know, toggle IMU. So I don't want the IMU to send me messages anymore. I just want to put it to false. My action will, my buttons will work on this action. So you have to play with this, and then you save the data, reset it, or load. Yeah. And here is how it works. Basically, when you select one of these, if you press save, it's going to save what setting you put into this table state, which is, you can see over here. Now, those settings are settings for messages that can be sent from the dashboard. But if I remember correctly, Radu also went through this in the kickoff, and yeah. Basically, for this, again, if you check it and press save, it will change what's the content of this JSON. If you just press load, it will just send it, and yeah, that's it. So this is in case you want to add some custom messages and you want to send some data to the system. You can put it here. Yeah, and one other thing that we didn't mention during the kickoff is this calibration method, calibration procedure. Basically, if you click here, you will have a series of steps or documentation of how to calibrate the steering and the speeding of your car. Because when we send the car, we just check that they worked, and here is yeah, how you have to place the car. You just put a tape on the ground to create an Y, then you press continue, and then you take those 3 dimensions. So it's a series of steps that you have to take continuously, and in the end, it will take out a graph like this. It's going to be like, hey, the offset of the steering. So if you put the car in 0 degrees as it is right now, it's actually minus 4.36 degrees. And yeah, basically we'll check that if you give 0 degrees to steering to the car, it will actually go straight forward. Similar for the speeding calibration, so it will check that, hey, if you give a PVM of whatever, it's actually a speed of minus 57.7, for example, speed. Yeah, and more times you do this calibration, more accurate it will get, because you do the calibration on very bad data or input. Then you have a better estimation of what a certain steering or angle means, steering or speed means. If you do it again, you all calibrate it again. So more you do it, in theory, better it should get. But yeah. Yeah. And after that, in the end, it will generate 2 embedded files, so C and H files. And in here, Radu will also show you how to actually put it on the embedded code and how to build the code and how to flash it. But I won't go through this right now. Yeah. Is this pretty clear? I know it can be pretty overwhelming, but anyhow, in the process dashboard, if you want to be like, hey, there are some messages that are running on the dashboard, and I don't want to show them in this table, JSON table, you will just have to handle them from here. So you can add an if, like saying like, hey, if is this message, I want to show it. If it's not this message, I don't want to show it. Because here you see for all the messages, you create a subscriber. So yeah, if you don't want to show a message, you just don't create a subscriber for it. Alexandru, please.
Yeah, I have a question regarding the calibration. We actually did actually tried doing it, but midway through, it just took us to the previous step after we submitted the current one. So we submitted step 2, the left calibration. We added in all the values, but then at the last sub step, we hit submit. Then it sent us all the way back. Is that supposed to happen?
No, that's not supposed to happen. Yeah, let me write it down, and we are going to check on it. So
May have been a connection issue or something. I don't know, but it worked. So the front end actually worked, but it just sent us back.
Okay, so from the 7th step, it sent you back to the 2nd?
No, we were supposed to go to the 3rd step, to the right calibration, and it sent us back to the left one. And it didn't actually give us the graph, the plot.
But the graph it gives you in the end, so at the end of everything.
Okay, but yeah, still it sent us back after we submitted everything for that step.
So you were in the 2nd step, and when it was supposed to send you to the 3rd?
Yeah, and it sent us back to the beginning of the 2nd again.
Okay, so it was like making you submit the 2nd twice.
Exactly.
Okay. Let us check on it, and we'll be back with a reply. Yeah.
And actually, I have another question. I wrote it in the chat, but maybe you didn't see it. It's a mechanical one, if that's okay.
Yeah, please.
Yeah, so multiple screws that came in to our differentiators were stripped, so we couldn't actually unscrew them to do the maintenance. So what are we supposed to do? Because we'll just break them if we.
Yeah, just try to do your best to remove them. I wouldn't know what to tell you. Yeah, because those screws are of material that's very easy to break, and if you're not
Yeah,
careful, I mean,
we
not
figured
you
that out.
directly. Yeah, if you're not careful, they ruin themselves. But yeah,
Yeah, that issue is repeated like for 3 of the 4 screws on the top of the differential.
just try to remove them somehow, maybe with a drill or something.
Yeah, but the problem here is if we use a drill, then the plastic around it will break. Can we get some kind of 3D model to reprint it, or I don't know, some link to the actual differentials and not the whole chassis? Because I didn't see that included in the list.
We don't have a 3D model for that. Maybe you can manage to find one, but we don't have it, and I'm not sure if they do, or if someone does. But you have the model of the chassis. The chassis came with these differentials. Maybe you can find someone who did something similar.
Then is the problem if we make our own, like 3D print the actual bodies?
No.
The differential?
No, it's not a problem. You can
We
do
have
it.
to include them then in the
No,
table
so
with.
no 3D printing or custom boards or whatever, they are not to be included. So even if you print something or if you want to make your own custom PCB, that is not included in the price.
Okay.
Sorry.
Yeah.
And I will say that we have 3D scanned the body and to frame too, but frame scan is pretty low quality for now. Maybe I will rescan it again, but for strategic dimensions and places, this frames can also work, and I will share it when I'm ready, maybe in the next weekend. So if somebody need that, he can use it too, and it's a BMW body. But I think frame is same for everyone.
Well, it's pretty similar. So yeah, if you manage to scan it accurately, put it there. We can also include it in the documentation. So yeah, thank you. You can put it on the forum or send it to us, and we include it in the documentation, however you want.
I will make a public link and send it to the forum, and everybody can download it after that.
Okay, thank you. This one we answered. Okay. Any other questions related to the brain?
I have a question regarding the state machine.
Yes.
And the system modes now are like default, auto, manual, and so forth. Would that be also where if we add like a state machine that says, for example, highway or waiting for intersection or stop sign or whatever? Would that be where we add that, or would we implement our own state machine for that somewhere else?
No, you can add those states over there. That's for sure. Yeah, we actually suggest to add more states, because this means that your code is getting more robust. So yeah, feel free to do it.
All right, thank you.
You're welcome. Even if those states don't fit you, so if you believe that legacy and manual for you is the same, just remove one of them. So yeah, it's just an example. It's not something that you have to have. Again, I don't remember if we mentioned it during the kickoff, but the dashboard is not mandatory. So if you want to build your own or a different one, or the code is, you can do it. So just what you have to take into consideration, if you changed, I mean, you have to show a dashboard. If it's ours or your own, it's okay. For example, the guys from last year, the winners, they did a very nice dashboard. Maybe you can get some inspiration from them. Yeah, let me find it. I mean, Radu will send it to me because I don't want you to. Yeah, but yeah, you can develop your own. Yeah, as you can see, they made some kind of a 3D map. Yeah, it's nothing like ours, but if you want, yeah, feel free to add whatever and also change the state machine, and yeah. This actually during the track. Okay, anything else? Okay then, thank you so much for being here. I hope this meeting helped. If you have some feedback, just write it down so that we know for the next time. Yeah, you can write it here or on the forum. If you would have liked to see something else, something more, or something less, yeah, just let us know. This way we know if you are doing something that helps you or something that is not helping you. Yeah. Thank you so much for joining. Next week we will meet for the embedded talk.